perform this calculation, we have to be aware of the solution from the previous part, which was the Compton shift. So I'm just going to write that down. We ended up with a value, delta lambda, equal to 3.82 times 10 to the minus 12 meters. Now, we're asked to figure out the change in photon energy between the incident photons and the scattered photons. Now, to do this, we just need to recall the energy of a photon, so we know that E is hc over lambda. Now, h and c are obviously constants. Lambda is what's changing by the Compton shift. So we have an initial wavelength, lambda I, equal to 2.35 picometers, or 2.35 times 10 to the minus 12 meters. The final wavelength, lambda f, is our initial wavelength, so 2.35. Now I'm just going to leave the exponent off till the end, you'll see why. The shift in wavelength is our initial wavelength plus the Compton shift, so 3.82. And of course, they're both to the same order of magnitude, so the same power of 10. And that's why I've been able to factor that out of both numbers here. 10 to the minus 12. And that is in meters as well. Now that we know the initial and final wavelengths, we can observe that the change in energy is final minus initial energy, E final minus E initial, which is equal to, so our final energy is hc over this final wavelength, so 2.35 plus 3.82 times 10 to the minus 12 meters. And then we'll minus our initial energy, which was just 2.35 times 10 to the minus 12 meters. So this is all just numbers you could put into a calculator at this point, and you would get a change in energy of 5.23 times 10 to the minus 12 joules. And that's actually negative. Now, oh, sorry, I made a mistake in the exponent there. That is 10 to the minus 14. Now, what that actually tells you, the fact that it's negative, is that the final photons have less energy than the initial ones, the ones that came in. So that makes sense because the scattered photons, the final ones, have a longer wavelength and a correspondingly lower energy. But that there is our shift in energy under these circumstances.